Hello, everyone. Today we'll be doing together the GitHub and Flutter webinars. So it's going to be a webinar composed of two parts. The first part will be GitHub, and the second part will be an intro to Flutter, how to set up your environment, and a quick rundown of how widgets work in Flutter and how to create a state-managed application. I am Stefan. I've been collaborating with a couple of companies I'm sure you already know. I've had some talks at DevTalks and DevCon, and I am also part of the organizing committee of the National AI Olympiad. So let's get started with the Git and GitHub part. The thing that you must know for Git and GitHub is the fact that they are two separate tools. Git is the actual thing that versions your code, and GitHub is just the remote cloud copy of what you have locally in your Git folder. The idea with Git is every time you make a change, you try to version it such that you can go back in time to a working version, or you can see what code change caused a certain issue that you've had. So Git is a version control system. As I've already told you, it will handle any change related to your files, and it's very easy to use because it has built-in support in IntelliJ VS Code and any other tool you would use to build your application during this contest. To create a GitHub account, so Git can be used without an account because it's a local thing, but if you want to sync it, and you will have to sync it in order to submit your code for this contest, you should create an account in GitHub. So you have the link here for the sign up process. I will also open it in a web tab to show you how that works. And then you'd be able to push your code to GitHub. I'll show you like step by step how to do it, and step by step how your repository will look like in GitHub when we go to the actual live demo part. So you have to know a few concepts for Git when you use it. The first concept is the concept of a repository. It is basically the place in which your project lives. So your repo is the full copy of the folder of your project. Usually your Git repo is initialized directly in the root of your project. So it's not like a folder in a folder, it's directly in the folder of your project. So if you have a folder named my application, your Git repo would be directly in that folder. Usually you would create a repo per application. So if you have, for example, 10 different apps, you would have 10 different repos. The naming convention for a Git repo is with a dash. So you can see it on the slide, it's GitHub dash repo. So for example, if you have, I don't know, let's say an application for cats, you would name it, I don't know, cat dash application. So if you have multiple words, you would do it like that. And you should know that Git is not a GitHub thing, it's a Git concept. So there, as I've said, two different things. GitHub is just the mirror of your local Git repo. If you want to create a GitHub repository directly from IntelliJ or from Android Studio, because they work the exact same way, I have some quick screenshots you can reference later on the slides. You just have to, after you have the project opened, in the top bar, that's how it looks on macOS, but on Windows you have the hamburger menu over which you, if you hover, you will have basically the same structure. If you tap on VCS, which comes from version control system, you'd have a drop down in which you can basically select share project on GitHub. If you tap on that, you'll be able to name the repo. In this case, it's demo, but you would usually name it like, I don't know, cat dash application. You leave remote the same, and then you also have a checkbox if you want the repo to be private or public. Bear in mind, for the context of this contest, you should make your repo public. So you should untick that private checkbox, which you see near the, to the right of the repository name. If you leave that checked, so if you make the repo private, the judges won't be able to see your code. So you should make it public. So this is a closer look. You just set the repo name and make sure to set it to public. So you should uncheck that, okay? Good. You may have some files that you don't want to be in the GitHub repository. For example, build files, so the build folder, or environment files like that we would usually contain credentials or stuff like that, you should ignore them. Git has built-in support for ignoring files because by default, when you init a Git repo in a folder, it will track everything. But if you want to skip some files, it's very easy. You just have to create a file that's called .gitignore. So that's the file has to be named like this. You can't name it anything else. And in there, you would place the files that you want to ignore. You can see you have multiple ways of ignoring files. You can either ignore files by their file type. So anything in the example on the slides, anything that ends with a .class will be by default ignored. Anything that ends with .log will be by default ignored because that's how I've configured it. The star means like anything to the left of that will be basically ignored. So it's very easy to ignore build files or build outputs. And for folders themselves, you just put the folder path and then you put a slash, and then that entire folder will be ignored from Git. So for example, in this case, on line 13, you have migrate working directory. If you have that in your Git ignore, basically anything that's in the migrate working directory folder won't exist on Git. So just make sure, especially since the repos will be public for this contest, make sure to have a very good git ignore file such that you don't commit any API keys or any credentials, because anything that's public on GitHub can be found on the web. So you don't want your API keys to be public anywhere. Good, that's the second concept. So we've had so far repositories and ignoring files. Let's see how we can actually track changes. We have the concept of a commit. A commit is basically like actually setting a change in stone, quote unquote. So after you do some changes to your files, you would usually commit them. So for example, if you're working on a feature, let's say adding, I don't know, changing the color of a button, after you finish doing the work that you have to do, you would most likely commit that change. It's very important to have quite small commits such that you can always revert a commit or go back in time. Because if you have very, very large commits, so if you commit rarely, then you would have a hard time actually using the features that Git is supposed to offer you. So make sure to commit often, even if it's like a few lines of code or a few files. Just commit them. Committing is just creating a new entry in the Git history, and this will be created locally on your machine. If you want to see this in GitHub, you would have to also push it. So as I've told you from the beginning, Git and GitHub are two different things, but they are kind of connected together. So committing is a Git concept because you have it locally, the commit itself, and pushing it would push it to the GitHub repository. Another mention here, when you submit your code, since it will be submitted via GitHub, if you just commit your changes, that's not enough. Obviously, you'll have to also push them in order to for the juries to see the code. So make sure to always commit and push. Usually, you don't only commit, you do both at the same time, and you have shortcuts for both. On macOS, it's Command K to commit, and then you have a commit window, and Command Shift K to push. And on Windows, it's Control K and Control Shift K to commit and push. You also have ways to commit files using the IntelliJ interface. As you've seen a couple of slides back, you had the version control system button at the top, but after you initialize the repo, that will be replaced with a Git button, which you can see in the screenshot currently on screen. And that button will have a menu with the options to commit, push, which will basically do the same thing as the commands that I've told you earlier do. Good. I've mentioned you can go back to an older version of your project. For example, let's say you've changed the color of a button and you want to go back, but you don't want to manually revert those changes because everyone's lazy and you don't want to rewrite code. It's pretty straightforward from IntelliJ or Android Studio. You just have to select the commit that you don't want anymore. So for example, if you open the Git log, as you can see in the screenshot, it's the button with that's on the bottom left. You will see the entire history of the commits, and then you can right click on a specific commit and you can either revert it, which will basically, let's say we've made a button from green, we've changed it to be blue. If we revert that commit, we'll have a new commit that automatically changes the button back from blue to green. You can also reset the branch to a certain point in history, but be mindful that resetting a branch will basically erase the commits, all the commits before that one. So for example, let's say I've made the menu blue and that was a commit, and then I've made the button green and that was a commit, and then I've also added a search bar. If I revert to the first commit, so if I reset the branch to the first commit, then everything in the application after that point will be gone. So all that code will be gone. So you should really be careful how you use revert and reset. Usually, at least for your use case, reverting should be enough, meaning you don't want to change anymore. You just kind of erase that one from the code base. So this is quite useful, especially if you add a lot of changes and people work in parallel, because if something breaks, you can always go back with ease and then try the implementation again. The idea with Git was anyway to be a collaborative thing, so it's very easy since you are also in teams of multiple people to work on the same code base. Good. So this was creating files directly from creating the repo and pushing and committing files from IntelliJ or Android Studio directly. It works thus in a similar way in VS Code, but the images here are from IntelliJ based IDEs. But the concepts are the same because these are not IntelliJ specific concepts. There's another way in which you can add files to your GitHub repo, especially for if anyone uses tools that don't write the code. So if you have something with drag and drop and you don't have the code itself, you also have to submit for the juries the archive. For these cases, you can directly upload these to GitHub. So on the next slide, you have a quick tutorial on how to do that. First, you will have to create the repository from the web interface. So when you open GitHub and you log in, you'll have an UI that looks like the first image at the top, and you'll be able to tap on the new green button. That will move you to a new page in which you can create your repository. So you'll have the second image, basically, which is a create a new repository. You can choose a repository name, in which case, in this case, I've also set it to demo, but you should set it to something specific to your application. And then at the configuration step, also make sure to have in the dropdown selected public. In this case, it's by default public. In IntelliJ, if you remember, it was by default private. And then you just press on the green button with create repository, and that will create your repository, which will move you to a screen that looks like the one in the top left part, in which it tells you how you can add files. It gives you some commands, but we'll ignore them for now because this is the uploading files via the UI part. So you have a small text in blue which says upload an existing file. It's in the quick setup section. So in the quick setup section, which has the blue background, you also have some small text which says get started by creating a new file or uploading an existing file. If you tap on uploading an existing file, you will be moved to a screen that looks kind of like the one in the bottom right part, where you can basically drag and drop the files that you need to have in your GitHub repo. And then in this case, in the screenshot itself, you can see that I've added a file, which is called mobile and embedded lecture 1.pdf. And make sure to also press the green commit changes button, because if you just exit now the page, you won't have the changes added to your Git repo. So just make sure to also press the commit changes green button from the bottom of the screenshot in the right. Good. There's also another concept, which is the one of branches. You have two types of, let's say, mindsets when working with with Git repos. You can either do trunk-based development, which means you just commit everything to main, so everyone just works in parallel on the same main branch. Or you can do branch-based development, which means for every feature that you do, you create a branch, you commit the changes to that branch, and then you merge that branch into the main branch. For example, if we go back to the button analogy, if you would have, let's say, to change a button from green to blue, you would create a new branch, name it, I don't know, green to blue button. You would push your changes to that branch, and then you would create a pull request inside your repo to merge the changes. For the contest itself, branches won't really matter. I'm just presenting these to give you a full picture of what you can do with Git and GitHub. But for the contest itself, you can just commit everything to main, and that would be fine. The goal with branches is if you have like very large teams of multiple people, they would be able to easily work in parallel because they wouldn't have to always sync their local copy with the remote one. So you have here the description of what I've already told you, and this is another screenshot from IntelliJ. It's the same again in Android Studio. If you see here, compared to the screenshot we've seen before, like a couple of slides back, we have multiple, on the left side, we have multiple kind of different colored lines. Each of that line represents a branch because obviously these commits are like a part of them are on main, some of them are on a separate branch, and so on. So in order to easily see which commit on which branch is, you have this view in the Git history thing from IntelliJ, which shows you easily like which commit on which branch is. Especially if you have like multiple branches, it looks pretty nice and colorful. If you only have one, it will only have a single line on the left side, and all the commits will be kind of added there. The dots on the line themselves are when merge commits occurred. So when one branch was merged into another, you will see a dot on that specific line. Good. And to merge a branch into the main branch, so basically automatically moving the commits from a branch to the main one, you have the concept of pull requests, which are, you just create a pull request and then you can merge it into the main branch. I won't insist on this one. And this is another concept which won't matter for the contest itself, but it's a nice concept to know. You have the idea of CI/CD pipelines. I'll briefly go over them. The idea with these is to make your life easier when you actually deploy your application to real users. You don't want to manually build every time the app and then upload it manually to the Google Play or Apple App Stores. You just, so if you have set up some GitHub actions or something similar, it would work something like this. When you do a change and you push your commit, in GitHub, it will automatically start something that will build your application, run some tests, and then it would automatically push it to Google Play or Apple App Store, from which your users, after processing, will be able to download the update. So it would kind of speed up your development time when, like, from the actual change until the actual update process, because you don't have to, like, this build and test steps you would have to manually do on your machine before updating it to the actual users. And also then you would have to take the build file, so the .aab file or .apa files, and then manually adding them into the stores themselves. So that would, you know, take you some time. In this case, just push the code and you ignore it, and then it would automatically do everything you want to. Good. Now, this is a very important section for actually submitting your codes to the contest. So please be mindful of this. All you have to do is these 3 steps. You have to use GitHub to version your code. So from IntelliJ or Android Studio or your preferred tool, you'll have to create the repository and push commits with your changes. The GitHub repository must be set to public, so make sure it's not set to private. The easiest way to check is just open an incognito tab and then paste the link to the GitHub repo in that one. And if you can see the repo itself and you don't get a 404 error, then that's fine. If you get a 404 error, that means that the repository is private and you need to make it public. And you will have to fill a form. We'll give it to you on the groups, and that's where you'll have to fill in the link to the GitHub repository. So please make sure you use GitHub to version your code and you set the repo to public. Good. Now I'll show you how GitHub actually looks like in my browser, and we'll quickly go over these concepts together. So if I open GitHub, you'll have a page that looks something like this. You have a sign in and the sign up button. If you already have an account, just use sign in and you'll be able to specify your username and your passwords. If you don't have a GitHub account, you just need to click on the sign up button, or you can directly click on the link I've given you on the slides. And then you can either use Google or Apple to sign in, or manually specify an email or a password. After you've signed in, you'll see a page that looks like this. Okay. To the left, you have the new create repo button. You'll have your repositories also to the left, and you'll also have your profile here. When you create a new repo, you just have to, so if you don't use IntelliJ, you can create a repo directly from the GitHub UI. Just tap on new, you select a name that's unique to your account. So the GitHub repo name, these don't have to be unique across the entire GitHub. These just have to be unique to your account because the URL contains the account itself. You would choose, in my case, I have multiple things, so I just had to use the owner, but usually if you have only one, it will be auto-selected. You can see that I already have a demo repo in my account, so I'll name this demo-2. Set your repository to public. In this case, it's automatically selected, so this is already public, and then you just have to press on create repository. Manually uploading files can be done from this button. So upload an existing file and then you drag and drop the file here and then you press on commit changes. If not, you can follow these instructions to connect the GitHub repository to the local Git repo. Since you have multiple people in your team, you would want to add all of them to this repository. So even if the repo is public, you'll have to add your collaborators to it such that you can directly add commits without any other issues. So you would go to settings. So right here you have the settings button. And then you have this collaborators section to the left in the access section. So you just do that. You have to use your two-factor authentication method for this one. And then you'll see this page where you can add people. So you can search for people here. You just select them and you just press on add, and this will add them as a collaborator on your repo. If by mistake you've made the repository private, so you can see public repos have the public label here. If it's private, it will say private or it will have a lock icon. If it is private, you just go again to the settings, you scroll to the bottom, and then you press on the change visibility button from the danger zone section. It's pretty easy to find, and you will have change to public, which will make it public, or change to private, which will make it private. After you do that, you'll have to confirm and then confirm again, and then you'll be able to actually change the visibility. So in this case, I've made this one private. Yours should be public, so you shouldn't have this lock icon here. You can see that the label is private now. So let's go back and make this public again. Change visibility, change to public. You confirm 3 times, and then the lock is gone, and also you have the public label here. Good. Okay, let me delete this repo. Okay, so if you want to create a repository from IntelliJ directly, as I've said, you have a version control system button here. I directly have Git, and then you would share project on GitHub from that dropdown. Let's actually create a new one and show you how. So you would do new project. In this case, I've already selected Flutter. Next, you select the name that you want. Let's do demo 2. Yeah, sure. I have to like this for now. After the project is created, so you are in your project now. If you have a Flutter project, it will directly create a local Git repo for you. So you'll directly have the Git option, and then you have to go down to the GitHub section and then share project on GitHub, which in this case, this repo already exists, but you'll have basically the same pop-up as on the slides, which will allow you to push it to the remote. Good. And for the commit history panel, you have on the left side the button that's like at the bottom of the page. It will open this section in which you can see the commit history, who committed them and when. So you have also the date and time. If you want to revert a commit, you just right click on it and you'll be able to revert the commit. This again will basically invert your changes. So if you've made a button blue, if you revert the commit, it will automatically make it back to its original color. When you view a commit, you can see what changes were performed to the right side. So for example, if we go here and we double tap on one of these files, you will be able to see what has changed. In this case, it's just a new file that has been created. So that's why everything is green. But if we open, let's say, something else, I will be able to see easily the fact that on line 6, originally this version was 6.2.0 and now it's 6.3.0. It will work in the same way for code changes themselves. For example, if I open a code change here, you can see that this line has been changed and these have been added, and the same here. Usually when stuff is removed, it will be with red. When stuff is added, it will be with green. It's pretty straightforward. Okay, closing this one. If you have any questions, you can obviously address them on the WhatsApp group or directly in the YouTube live chat thing. Good. Okay, starting the Flutter part. Okay, so the idea with Flutter is you just write your code once and it will automatically build the same UI for everything that you need. So for your Android users, for your iOS users, for your web users, and also for Windows, macOS, and Linux. So you can basically support any platform you want just by writing the code once. There's a small caveat here. It depends on what features you want to use, but usually for the like 90% of stuff you want to do, Flutter will out of the box work for you on any platform you want. So if you want something that easily works on any device using any operating system, you can just use Flutter. So this is what I've already explained. You write the Dart code once, and it just runs everywhere you need. Here are some applications that already use Flutter. So you have the BMW car app. You have a lot of stuff like Alibaba, ByteDance, stuff from Google, like Google Ads. And in the past 2 months, I think a lot of banks from China started also using Flutter. But Flutter is developed by Google. On the bottom right side, you have like the Google Trends search comparison. It's from 2022 to 2024, I think, because it's an older screenshot. It's an older screenshot, but it just compares how many people search for Flutter and how many search for React Native. Flutter is the blue line, React Native is the red one. So based on this metric, Flutter is twice as popular compared to React Native in Google searches. Okay, so Flutter is open source, so you can, if you have any issues with it, you can obviously open their GitHub repo and start fixing things. It uses the Dart programming language. It's very similar to Java, but it's not as verbose, so that's nice. And you can create with it apps that work on any platform you need. And also bear in mind, compared to React Native, your application will look the exact same on any platform that you run it. So if you have a button that you have a custom style for it, it will look identical both on Android and on iOS. In React Native, when you do a button, it will have the native styles of that platform. So on Android, it will look like an Android button. On iOS, it will look like an iOS button. So it really depends how you want your app to look like. So if you want that native look, you should use React Native. If you want something that looks the same and also works on any platform your users are on, you should use Flutter. Good. And an advantage compared to React Native, you have support for web and desktop, so macOS and Linux. And you also have any browser you want. And this is done because Flutter uses a canvas component and renders everything from scratch. When you develop Flutter apps, you would have a workflow that looks something like this. So you could use either Android Studio or IntelliJ to write your Flutter code. You push the changes to your version control system. And then, as I've said in the GitHub part, you would have pipelines that automatically build for the two stores. Pipelines are a very nice thing. I actually use them for my apps. And all I have to do is just push a commit, and then a couple hours later, my users get the update itself. Good. To develop Flutter apps, once again, you would use Flutter. You can use IntelliJ or Android Studio. You can also use VS Code if you prefer. And if you have a MacBook, you can also use Xcode. You have the links to install the Flutter SDK. It's the docs.flutter.dev/install. You just click on that and you'll have to download an archive from Google. And in IntelliJ, this tutorial will be IntelliJ based, but it's the exact same. So the UI looks identical and everything is identical also for Android Studio because they're based on the same platform. Unfortunately, on the slides themselves, I don't have a tutorial for VS Code, but it would work the same way. So you just search for the same plugins and that should be fine. Good. So after you install the Dart SDK, you would need a couple of more things. You would need the Dart plugin. So in the plugin marketplace for IntelliJ, you just search for Dart and you install it. And you would also need the Flutter extension. Same way, you just search for Flutter and then you tap on install. When you have to do a new project, you just open IntelliJ and then you tap on new project as I've done earlier. So new project, then you would have these two models that would pop up one after the other. So the first one is just for you to select where your Flutter SDK is located. So in this case, it's at that path for my machine. For yours, it might be different. And also bear in mind the version number because that will most likely change. And in the next pop-up that you have, it will have the actual project details. So the project name, in this case, it's Flutter_demo, the location itself, a quick description, which I always leave the same. The organization, which will be your package name. So your package name will be whatever you have in the organization section plus your project name. So in this case, it would be com.rusudinu.flutter_demo. So by default, it's com.example. Usually, you either use your company name or your name itself in order to create a package that's not with com.example. For Android language and platforms, I just leave these unchanged. For the platforms, everything's by default checked. So you have Android, iOS, Linux, macOS, Web, and Windows. And in the more settings part at the bottom, you have the actual module name, which is most likely the same as the project name. These are automatically filled. And the content root and module file location the same. So you wouldn't usually touch these. And after tap on create, your project will be created. So if we go in IntelliJ and create a new Flutter project, so let's close this one. So you just have to tap on new project, which is the button here. So you do new project, you select Flutter, you have this most likely automatically filled. If you don't, you will have to find it. Usually so if you are on Windows, this will be automatically filled. If you are on macOS, just put the same path as I did and be mindful of the version because that might change, but the rest of it should be the same. If you need to know the Flutter version, just do Flutter version and you'll have basically the currently installed version. In this case, it's different from this one because they are symlinked, but for you, you'll have to just add here the version that you see here because that's what your path will be like. And you can also do where Flutter, and it will tell you kind of where this is installed if you want to kind of guide by something how the path would look like. Okay, let's just do next here. I should title my project and I'll do demo 2 in this case. I'll put it somewhere else. I'll change the package name and then you should be fine. You can just tap on create. You have to wait a couple of seconds. You'll have the project created. And this will open you in the kind of default example Flutter code. And you can see the structure of the project. You have the lib folder where all your code will live and the files will be with .dart. If we actually run this application in IntelliJ or Android Studio, if you have the plugins installed, at the top you will see something like this. This one is the device selector, so you can select the target on which your code will compile to. So in this case, I don't want macOS, I want the emulator itself. You can either open an iOS one if you are on macOS, or you can open an Android Studio one if you are on Windows. You can also open an Android one if you are on macOS, but I will just open an iOS one just for the sake of having it open quicker. So I have the emulator here, and now to run this application, all I have to do is press on this button, which will start the app on the emulator itself. So you can see that the build has started. You'll just have to wait a couple of seconds, depending on how large your application is, for it to compile, and then it will show up on the emulator itself. Okay, so now that that app has started, you can see the UI of the basic Flutter application. So by default, when you have an empty project in Flutter, it will be created with these components. It's also a good example of stateful components because if you click on this plus button, it will automatically increment that. If you want to choose another device, you can just choose it from the list. If you want to stop the application, you just have to press on the red button and it will stop it. Good. Let's go back to the slides themselves. Okay, so we've created the project. This is how you select a target. You also have kind of the same screenshots on the slides, because if you prefer to follow the slides themselves, you can just reference to these. A very important part in developing your application is the concept of packages. These are pre-built, let's say, kind of code, or you would use them as tools, I guess, which help you build things quicker. So in this case, if you want to connect to a backend service or to an API, you would need the HTTP package, which you can get from pub.dev /packages. So if we also open that now, you can see that you have a page like this, and in this one you can search for any package that you want. For example, you have shared preferences ones, HTTP ones, and so on. Let's say you want something with images, you can just search for image, then you press on enter, and you would be able to see all of the packages that are related to your search term, so that are related to actual images. Let's say you pick this one. You will be able to see a quick documentation usually, which is directly on the page that opens. So you can scroll down to this one and read whatever the developer wanted to tell you. You have the changelog. This is pretty useful if the package version is updated and something broke in your application. You can take a look at the changelog of that package and see what has changed and what you need to change in order to make it work again. You also have an installing section, which tells you how to install the packages in your application. You have multiple ways. You can either use this command in the terminal. You can also use this one, which will do the same thing, or you can manually add the dependencies to your pubspec YAML file, which in the file tree is at the root of the project. It's this one. When you freshly create a project, it will be by default filled with a lot of green comments. You can just delete these. So a cleaner one would look something like this. And you just take this part, you go back to your IDE, and you add it to your dependencies section. Be mindful you have two sections, one with dependencies and one with dev dependencies. If you need something that will work on the user's phone or device, you should add it to the dependencies themselves. Most likely, all of the packages that you will need to add, you will add them in the dependencies section. The dev dependencies part is only composed of packages that need to run on your machine while you are developing the application itself. These would be things like stuff that helps you run tests, stuff that auto-generates code, builders, linters, and stuff like that. So if you, for example, need to add Bluetooth capabilities to your application, it will go to the dependencies section. If you want to add a new code formatter, you would add it to the dev dependencies section. Good. After you add a package here, if you go and try to use it in your Dart file, it won't work by default because you've just added it to this file, but you haven't actually told Flutter that you need that code. So in order to do that, since you have the plugins installed, you have a few options here as Flutter commands. You have pub-get, pub-upgrade, and pub-outdated. If you add a new package, you just do pub-get. The equivalent would be to actually write in the terminal yourself, Flutter pub-get. But you can do this, you can just click on this and it would automatically do the thing for you. And in this case, it added, so the images package was already here, but after I've pressed pub-get, it actually downloaded it and I can now use it in my files. Be mindful that in this YAML file, you will also add any assets that you need in your application. For example, if you use any images that are shipped with the app, so stuff that's in your assets folder. Let me open a better example for this one. So if you take a look here, you see that it has a lot of dependencies, and then you have an assets section in the Flutter group, which specifies which local assets will be bundled into the application. So if you take a look at the assets folder here, it has some data. So they are obviously added here. If you don't add them here, you won't be able to reference them in your code. So if you, for example, use an image that is in the assets folder and you haven't also added that path here, if you try to render it in the application itself, you'll basically see an error section. If you add it here and then you use it, you'll see the image itself. So be mindful if an asset doesn't work, most likely it hasn't been added to this assets section. Also, if you want fonts, they are also added to this section. So it's similar to assets, but you just specify that it's a font. If you want to have an icon for your application, you have two very helpful packages that will go in the dev dependencies section, which are Flutter Launcher icons and Flutter Native Splash. When you add these two, you also have the ability to add these parts of configurations to your YAML file, in which you can basically say the icon for my app should be this one, and you also have iOS and Android separation if you want to have different icons, and you can also set the background and foreground for adaptive icons. And for the splash itself, you can set the color, the image, and also the dark mode things. You also have a couple of extra params, which is like how to center the icon, if you want it centered or not, if you want it to be full screen or not, and so on. After you add the icons, you just have to run these two commands. So this one to create the splash screen for you, and this one to create the app icon for you. So after you run these commands, these will automatically generate all the files needed for your app to have the correct icon. So you don't have to modify anything in the iOS or Android folders. This will automatically do it for you. Because by default, when you have a new app, so you can see the demo 2 application has this Flutter icon, and obviously you don't want to have this, you want to have a custom icon. And also when you open it, in this case it opens very quickly, but you would have seen a Flutter logo when the app starts. And if you want to have custom ones, you just have to do the changes to the YAML file that I've mentioned before. Okay, going back to the slides. When you add a package, you can specify a fixed version or not. So in this case, you see before the 1.0.8 section, like version code, you have this symbol. This basically tells the package manager that it can automatically update minor versions of this package. So for example, when you do pub upgrade, this will automatically become 1.0.9. But be mindful, this will become 1.0.9 for the actual log file. In this file, you will still see 1.0.8, but what's going to be packaged, it's going to be the 1.0.9 version. Good. So that's kind of the general view of how a Flutter application works and how you should set up your project and how you can add packages. If we move to the actual development itself, we have two ways of building widgets. We have stateless and stateful widgets. Stateless widgets are just widgets that show you things, but they don't do anything when interacted with. So for example, that button press that you've seen before with the plus button incrementing the counter, that's a stateful widget because on press state modifies. If it would have been stateful, you wouldn't have been able to press on the button and increment the counter. So stateless is just for showing static text, like If you want to show messages in your application that don't change at all or stuff like that, you just use stateless widgets. If you want to use things that modify on user interaction, most likely you would need a stateful widget. Everything in a Flutter application is structured as a widget. We'll go back to the demo project and I'll show you exactly how these are built. And every UI starts from a root widget, which is basically the thing that's firstly added to the tree. So in a regular application, you would have something like material app, then a scaffold, and then column and text. Column and text being the actual things that the user sees, but you need material app for material UI things and the scaffold itself in order to build everything that's specific to the regular UI that a platform has, for example, Android or iOS. This is a code example of a stateless widget. It's pretty straightforward. You have, so these can be automatically generated by commands in your IDE. So for example, to get this, you just do STLESS. I'll also show this to you in the IDE itself. And it's the same for stateful widgets, which are a bit longer. So in this case, you just have the build method and the text itself and nothing changes here. But for a stateful widget, you have two classes. In this case, you have the stateless text class, which extends the stateful widget, and you have the state itself, which has the state of that particular widget. In this case, it's the counter that you've seen previously on the emulator itself. And you have the text, which shows the count at which we currently are. So when the state changes, this will automatically change without you doing anything else in the code. If by mistake you've done a widget that's stateless and you want to convert it to stateful, all you have to do is on the extend stateless widget part, you just right click in your Android and you will be able to have, you will have this kind of menu that allows you to convert it to a stateful widget and the code will be automatically converted for you. So you don't have to do anything here. So if we look in the code itself for the demo application, we have a stateless widget at first, which just contains the application, some theme configuration, and the actual title. So you have a Flutter demo homepage. If you modify this to something else, when you press save, you will see, I think this is no longer started. Yeah, let me start it again. Let's go back to the regular one. So my point was when you do your code changes, as long as the app is started, you will see the changes apply in real time. So it has hot reload. If we do this and save, you will see instantly on the UI that this changes. And also it will preserve state. So for example, if my counter is at 16 and I change something and I press save, it will change, but the state will be preserved. So I don't have to start pressing this 16 times once more after I hot reload the app. It just has the state like already kept. Okay, let's change this back. Let's press on save. We have a stateful widget here, which is basically this counterpart. Like you have pushed this button this many times. This works in the following way. The thing that you know that changes on user interaction, which in this case is the counter itself, you just declare it at the top of the class. So you do counter, and let me actually maybe zoom this in. And you can also set the initial value, which in this case is 0. When you want to change the value of this variable and you want the user to see it, you just wrap your code like the change itself in a method that looks like this: set state, and it has a unnamed function and then the actual change itself. If I do it like this, and let's say I fully reload the app, when I press on plus, nothing will happen because, so it seems like nothing happens because I don't see the change itself. But if here, let's say I also print this counter, Let's do that, and let's take a look in the terminal itself. Okay, when I press, in the terminal I can see that the counter actually increments, so it goes 1, 2, 3, 4, but on the UI I still have 0. That's most likely because I haven't wrapped this in a set state. When I do that, whatever I see in the terminal for the variable will automatically appear on the UI. So it's very straightforward to actually show data to the user. You just have to wrap your variables in a set state block, and that will basically do the change. You can also do something like this. You can do counter and you can just leave that empty. That will also work, but it's not really a best practice because the framework doesn't really know what variable has changed. So in this case, it has to check everything, and then it will find that counter has changed, and then this widget has changed, and then it will change it. But if you do it like this, it already knows that I need to change counter, and then only this piece of the UI will re-render. So this will help with your performance. Even if you do this, it will in the background check, like if you have multiple variables here, it will check like, okay, has any of these changed or not, and then it will change them for you. But you should keep in mind that you should do changes only in set state blocks for the variables that you show to the user. Okay, you have a build method. In this method, you have the code that's actually shown to the user. Let me just remove these comments because they take a lot of space. Good. So this code is code that the user doesn't see, because obviously it makes no sense for the user to see like how I'm incrementing a certain variable. But for the content that the users see, I have it added in the build section, which is a special kind of part of the code of this class that builds the actual UI itself. So you can see that here I have in the default project set some things like this text, for example, which is you have pressed this button and then under it you have the actual counter itself. You can style components. These usually have like a style block to which you can add things. So Flutter widgets, a Flutter widget is basically this one. It's this app bar or this text or this column. And each widget can receive params. In this case, the app bar can receive multiple params. You can see them when you hover over one of them. You can see you have a big list of what this app bar can receive. But for this, you don't have to like specify all of them. You can have to specify only the required ones. In this case, we have the background color, which is the inverse of the primary here. We can just do color and then let's say this yellow, and when you save it you will directly see the color itself. And also you can specify, usually for each widget you can specify children. In this case this is named as title, but usually they're named either child if it has only one child. So for the center widget you usually have only one child, but for the column one you have multiple children because it's a column, and it's the same for the row. And you have the title widget, which has the actual title of the app itself. This is a variable. I can obviously directly replace it with this text, and you'll see it in the app when you press save. Good. Column and row widgets are a bit more special because you can specify how you want to align the elements themselves. This is kind of similar to writing CSS, but it's in a more like, let's say it's in a more imperative way. So if I replace this with a row and I press save, the text and the number will be like one next to the other instead of being one under the other. So let me press save. I have these aligned like this now. If you want to align them differently, you just have to change this param here, and you can do, when you do that, you have the values that you can add to it. So you have center, end, space around, and so on. If we do end, and also let me make this smaller such that you can see easily what happens. So on center, it will obviously center them on this row, because again, I'm on a row now. So you just think of it like one line. If I do start, they will be to the left. If I do end, they will be to the right. And you have two more special ones, which are space around, which will kind of space them like this. So it calculates how much space to the left and to the right of each widget I can add in order for them to look kind of like this. You can do space evenly, which spaces them. So the space between left widget, widget next widget, widget right, it's the same in this case. And space around, I think I've been over this. Space between will basically move them. So, you know, this one will be to the left, this one will be to the right. If I add a new widget here, it will appear like this. So be mindful that you can select how or set how you want each of these to look like. If I do column, it will happen the same thing, but vertically. So as you can see, I have now they are split like this. If I do start, they will be at the top. If I do end, they will be at the bottom. Space around and evenly, and the other ones work in the exact same way. Good. If you want to add floating elements like this button that still increments that text, you just do floating action button, but be mindful this property is only available on the scaffold widget. So you can't add floating action button on a column. For example, you'll get an error that says too many positional arguments. This means that basically that widget doesn't support this one. There are a lot of widgets that you can use in your application that are built into the Flutter framework. All you have to do to find them is just open the browser and just do Flutter widgets. And you'll be able to open this page, which contains the widget catalog. You will have to pick a design system, Cupertino or Material Design. Material will have material widgets. Cupertino will have widgets that try to look like the native iOS ones. If I select Material Design, I have the collection of widgets grouped by what they actually do, so actions, communication, and so on. If I open a widget, let's say I open segmented button, I will have a sandbox that shows me how I can use that widget. So for example, for this one, for the segmented button, I have this code sample, and it also renders a live example to the right. So you can basically have this view and you can kind of tweak it. When you press on reload, your changes will be synced to the right part. So you can kind of test widgets before you actually add them to your application in this catalog. It's very similar to storybooks if you've used them for web development. And basically you have here the entire widgets collection. You can choose and use either one of them. So for example, if we actually try and use a switch, all I have to do is take this code, go into my application. Let me also have the emulator to the right. Let's say I put this switch here. I will remove that and set it to true just for the sake of having this example. And I have the widget already added in the UI based on like the code that I've taken from the widget catalog. Obviously, in this case, this widget won't work because I've hard-coded this value to true. But if I were to make it actually work, I would have to do toggle value. I'll set it to false by default, and I'll just use it in my value here, and the set state. So onChanged is called when you actually press the button itself. So all I have to do is set state and set the toggle value to the like negative of the previous value, because when the user toggles a toggle, usually it wants to change state. So I just save it, and now I can use this switch in my application pretty easily, and I also have the toggle value itself. So for example, I can do things like, let's say if I want to increment this one only if the switch is on, all I have to do is put an if here. If the toggle value is set to true, I will increment, otherwise let's say otherwise I'll decrement. So let's do an else here, and then minus minus, and then we can do that. And when I press save, it decrements. When the toggle is on, it increments. So that's pretty straightforward. Good. You have also another way of managing state. So you have kind of the explanation briefly on this slide. There is another way in which you can manage state. It's a bit more complex. It's similar to React Redux, in which basically you don't have set states in each of the widgets themselves. You have kind of a state that's separated from the UI logic. This pattern is called block pattern. And in this one, the state is actually fully separated. So when you, let's say, increment the counter, you don't have the logic to change the counter in the widget itself. So you wouldn't have that set state part. But the disadvantage for this one is you have to do a little bit more setup. The advantage is you have the state available everywhere. So for example, the value of that counter will be available in any widget of my application in which I need to read it. I won't insist on this one because it's a bit of a tricky one. You have kind of a diagram on how this one works. Usually the UI will trigger the state change. This will kind of trigger some events in block which will change the state itself, and then the UI listens to those changes and then adapts accordingly. You have also the concept of a qubit, but I'll kind of skip this one. The more important part for you is the equatable part. I'll move back to the original demo that I've had, so not this one. I have a demo here related that shows kind of how equatable works. Let me quickly start it. So usually when you compare numbers, let me see. So I have this equatable one. When you compare numbers, 2 always equals 2. So let me actually have a more visual thing. So if you do, for example, if you print, this will give you obviously true in the console. Let's wait for it to build. But the problem is if instead of these numbers you have objects, then they won't be equal. So you see this give me a true. But for the case of actual classes, so for this one with a person, if I compare 2 persons, so if I do, and let's say I kind of give it, sorry, it's a standard person, and I give it a name. Let's say the name is B and the age is 20. If I have these two and I try to print if these two are equal, and I save it, let's actually not hot reload it. Let's restart it because it won't execute all of the code. You can see that for this case, you have a false, even though the person has the same values for the attributes. It's B and 20 for both of them. So this is basically the same. So you would assume that person A and person B are the same. In case of objects, they are not the same. This actually compared where these objects are allocated. So most likely it's wrong for my use case. So what I have to do is actually tell Flutter that if 2 persons have the same name and same age, they are the same person. So such that I get a true here. And I can do that pretty easily. There's a package that's called equatable. So for the class that you want to basically apply this, you just extend it with equatable, and you provide a list of props here that will tell it based on what kind of features of that object to compare them. So in this case, if I do equatable person here instead of the regular person, when I run the app again, it will also give me true because I've specified here name and age. If I remove age, it will just compare by name. So for this case, obviously it will give me a true again. But if I change the age, it will also give me a true again because I've told it to just compare by name. So here I've specified only name. So only on this parameter, the comparison will be made, and these two are the same. If I change this one to C though, and I run it again, I'll get a false because the comparison is done on the name. So be mindful of this. You can easily compare classes in this way, but make sure to always add everything you need to the props array. Otherwise, you will have weird comparisons like the one I've showed you earlier, where persons that are obviously different show as being the same or vice versa. So you can have this trick, but you just have to pay attention to it. The demo itself just kind of visually shows what I've already shown you in the terminal. By the way, you can find this like demo code and some other Flutter concepts in GitHub repository, which I'll provide on the WhatsApp group. Good. And for the final part of the webinar, we have a quick intro into DevTools. DevTools are an useful thing which helps you debug your application if you have any issues. Mostly if there are issues related to how the app looks like or its performance. So for example, if it kind of moves slowly, this will help you figure out what's the actual problem. So when you run the application, we'll also do this in IntelliJ as a live demo. You have in the console output some text that shows you like where the debug service is listening, which in this case it's that thing I highlighted with blue for you, but you have to kind of look in the terminal itself for it. When you open that, you'll have a page that looks like this and gives you some interesting things. I'll move to the live demo. These are on the slides just for people that look at this synchronously. So if I start the application itself, let's go there and let's start it like that. When you start it, and after it actually opens on the mobile phone itself, you can see that we have the same thing, debug service listening on, and then you have this URL. If you take it like this and you open it in your browser, it won't work by default. What you have to do is this part that starts with WS, you just have to replace it with HTTP. After you do that, you'll be able to see this page that shows you multiple subtools, which are the Flutter Inspector. This will show you the widgets that are currently rendered. Let me make this smaller and open the emulator. So you see we have this list tile with the tiles themselves, which are hello world, basic widgets, navigation, list view, and so on, which are exactly the ones that are rendered on the device itself. When you tap on one of them, you see different details like how it's aligned, what's the padding, and so on. It's very similar to how DevTools work if you open an HTML page in your Chrome browser and open the DevTools. There's a thing that's called select widget mode. If you tap on that, when you select a widget, it will actually show you how much space it takes directly in the UI itself. So for example, you see if I select the text, it's kind of this height, so 24 pixels high. If I select the list tile, which has some more padding, you can see that it's a bit like taller and has 64 pixels in height. The nice thing about this one is while I'm in select widget mode, I can tap on these and they will select the widget that I'm tapping on. So if I want to tap on an element and I don't want to search it in the widget tree itself, I can just tap it here and it will automatically also select on the left side the widget that I've already selected. But be mindful that while you have select widget mode on, you won't be able to actually perform any click events because in this application, if you tap on these, they actually open pages. So while you have this mode on, that click won't work, okay? Good. We also have some extra tabs that are interesting. Performance, for example, which shows you how much time a frame took to render. If you take a look at this graph, it currently isn't moving because no frame is rendering since nothing is happening in the UI. But if I tap on an actual part of the UI, then that will trigger some re-renders. For example, if I tap on this list view, you will see kind of a lot of frames that started moving. I'm sorry. Let's try that again. So let's move it to the left. Be mindful that at the bottom you have the actual frame number, so you can see kind of what happens. So let's move through the pages. You can see that it shows how much time each of these frames took to render. If you have anything that's red, that means that that frame took some time to render. You can tap on it and then you will be able to see how much the build took, how much layout resizing took, and so on, such that you can find out why this frame takes longer to render. Usually red frames, when perceived by the user, they will make the application feel kind of janky. So you should watch out for this, but you shouldn't like actually try to over optimize for this because since this one is in debug mode, the application will most likely work slower than when it's actually compiled. Because debug mode also has to have that hot reload and so on. You can also profile the CPU. You just move to the CPU profiler tab. You just press on that recording button. Let's do some things in the app just for the sake of having something in there. And when you press on stop, it will fetch them from the device and it will show you like how much time each method call took. And then you can basically investigate what's the issue with it. You can also see like if it calls some other stuff in the background and so on. Another interesting part is the memory chart. It shows you how much memory your application takes on the device. So for example, if you try to optimize for devices that have less memory or like less RAM mainly, you'll be able to take a look at this graph and see in which moments your application allocates more memory. So for example, if I start doing some things, you can see that it allocated some new objects, which is represented by the 3 dots here. And you saw that it was a very slight bump in memory allocation. Obviously, this application is not very memory intensive, so it won't allocate a lot of things, but when you have a more complex one, that's how you'll be able to actually see it. You have a debugger. I actually never use this one because you can use the debugger, which is already built into IntelliJ, and you also have the network tab, which shows you what network requests your application made. So when I press on this button, you can see that I have the requests here, similar to how you would have seen them in a web browser for a JavaScript-based frontend. And you can see what are the headers, what the response was, and an overview of the request, like how much it took, how much the connection took, and so on. If you want to open even more tabs, you have these kind of arrows here, and you have the options in that dropdown. And you'll be able to kind of see what happens to each of them. If you go to the deep links section, a deep link is basically something that opens your app directly to a certain screen. For example, if you want to open it directly to, let's say, this page, you would configure a deep link and you can test them directly from this page after this one loads. Probably I won't have anything here because I don't have any deep links configured for this application. Good. So that was pretty much it with the Flutter and GitHub tutorials. I will post the links to the demo code and the presentation in a PDF form on the WhatsApp group. And if you have any questions, I'll be available to answer them on the WhatsApp group. And yep, I think that was it with this one. I see no questions in either the WhatsApp chat or the YouTube group. So thank you.